Okay, we are ready to evaluate our first definite integral by taking the limit of a Riemann sum. So I want to take a look at the integral from 0 to 2 of 2x dx. I'm using a different scale on the x and y axis here just to make things fit. So there's the line y equals 2x over the interval from 0 to 2. Looks like I'm looking for this area right here. Now, obviously, that's a triangle. So I could figure out that my base is 2 and my height is 4, and that half of base times height would just be 4. Okay. So I know what the answer is, and it's going to feel really rewarding when we get it a long time from now. Because what we're going to do is, rather than just getting this by geometry, we're going to take the limit of a Riemann sum. So, first thing I have to do is set up the Riemann sum. So, I'm going to be chopping this into little tiny pieces. Okay, and I want to figure out the base and the height of each piece. Now, I'm going to be strategic, and I'm going to use a regular partition. So they're all going to have the same base, which I can call just delta x, and that will be the length of the interval, which is just right endpoint minus left endpoint, so 2 minus 0, divided by n. So each one of these pieces is going to have a base of 2 over n. Now that's a variable because I'm not doing a specific Riemann sum with 4 rectangles or 8 rectangles. I'm going to be taking the limit as the number of rectangles goes to infinity, and that's going to force this base to go to 0. Okay. So then I need to figure out the height. Now the height is going to equal my function evaluated at xi star. So I have to find a way of picking a representative x value from each one of these intervals. Okay. Now, the most common choices are right endpoints, left endpoints, or midpoints. Turns out, and it's kind of amazing, doesn't matter which we choose. Now, if I'm doing a finite Riemann sum, so I'm just estimating the definite integral, I'm going to get a different estimate if I use right endpoints, or if I use left endpoints, or if I use midpoints. But if I'm taking the limit of a Riemann sum, I'm going to get the same limit. They're all going to converge to the same thing. So I'm free to choose whatever sample point I want to. So what I want to do is just explore what would the formula be for describing an arbitrary right endpoint, an arbitrary left endpoint, or an arbitrary midpoint. And then, since it doesn't matter which one I use, let's pick the simplest one. Okay, so here's the picture that I have. Here's my x-axis, and we're going from 0 to 2. I've chopped this up into a bunch of pieces, where the length of each piece we've just determined is 2 over n. Okay, so if I were to find, let's see, I think I want some space here, so I'm going to just remember that my base is delta x is 2 over n. Let's say I wanted to find my right endpoint. So, and I'm talking about the right endpoint of the ith subinterval. So let's specify that, of the ith subinterval. Okay. So I'm going to imagine that I'm here, and I'm going to go for a walk to the right endpoint of the ith subinterval. But I'm going to pace myself so that the size of the step I'm taking is 2 over n. So if I start at 0 here, one step takes me to this, which would be the right endpoint of my first subinterval. 2 steps takes me here. That's the right endpoint of my second subinterval. 3 steps would take me to the right endpoint of the third subinterval. So how many steps will take me to the right endpoint of the ith subinterval? I. So my right endpoint is 0 plus I times 2 over n. Now what I purposely wrote the 0 plus because I'm not necessarily always going to be starting at 0. My left endpoint could be some number other than 0. So I'm viewing this as my starting point. And this is the distance that I traveled when I went on this lovely, exciting journey to the right endpoint of the ith subinterval. This I, that's the number of steps I had to take. Each step takes me to the next right endpoint. 2 over n, that was the size of the step. Okay. So I can sort of generalize this if I had a different interval, like let's say I was going from 1 to 5, I would be starting at 1. If I was going from 1 to 5, that's an interval of length 4. When I chop that up into n pieces, that would be 4 over n. So my step size would be 4 over n. But I can modify it. It's always the leftmost point plus the number of steps times the size of the steps, which will just be the same as delta x. Okay, so in this case, this is just 2I over n is the right endpoint. Okay. Let's take a look at a left endpoint of the ith subinterval. That's going to be almost the same, except if I start here at 0, I'm already at the left endpoint of the first subinterval. When I take 1 step, I'm now at the left endpoint of the second subinterval. So I'm just taking 1 less step each time. So it would be 0 plus I minus 1 times 2 over n. That's still the number of steps, that's still the size of the step, and that's still the starting point. So it's almost, but not quite as simple. It's 2 times I minus 1 over n. So far I like right endpoints better, because I got a slightly simpler formula. Okay. If I wanted to get midpoints, I could do that. The midpoint of an interval is just the average of the left and the right endpoint. So I could say this is the left endpoint plus the right endpoint, all divided by 2. That's how I would average them. So I can say, okay, that's 2 times I minus 1 over n plus 2I over n. I'm going to distribute that 2, so that's 2I minus 2 plus 2I all over n, because I've got a common denominator, 4I minus 2 all over n. I definitely like right endpoints best. So I'm going to go with right endpoints. And here's my rule for Riemann sums. If I'm asking you to do a finite Riemann sum, so use 4 rectangles, or use 5 rectangles, or use 8 rectangles, for that I can specify left endpoints, right endpoints, midpoints, create an upper sum, create a lower sum. You got to be prepared for any of that. If you're taking the limit of a Riemann sum, you may choose. So if you want to always choose to use right endpoints, you're allowed. Now, as you're doing the homework, some of the homework problems are going to say take the limit of this Riemann sum, use left endpoints, or use midpoints. If you want to challenge yourself, that's a great challenge. If you don't want to, that's okay. If you want to just change the directions to say, nope, I'm going to use right endpoints because that's strategic laziness. Right endpoints are simplest, and if I'm taking the limit, it doesn't matter which point I choose. So, you have my permission to use right endpoints if you want to. I'd encourage you, if you're feeling comfortable with this, to challenge yourself to follow the directions in the homework and occasionally use left endpoints or midpoints. But if you're struggling with this, just work on getting the right endpoints down. Okay. All right. So, if I want to get the height, I've now decided that that's going to be my function evaluated at my right endpoint. Now getting that is a two-step process because I have to first of all find the right endpoint and then plug into the function. So the right endpoint is what we just found. We said that's going to be 0 plus I times 2 over n. Starting point plus the distance we walk, number of steps times the size of the step. So that's just 2I over n. But then the height is my function evaluated at 2I over n. Now the function, the integrand here, is just 2x. That's the x value that I'm plugging in. So I'm going to get 2 times 2I over n, or 4I over n. So this is my height, this is my base. So now, I know I'm going to create a limit of a Riemann sum. Let's write out the sum. It's going to be as I goes from 1 to n. I've chopped things up into n pieces. What I'm adding up is the area of the ith rectangle. But I calculate area as height, 4I over n, times base, 2 over n. So that's a sum of areas in a triangle. Notice I'm going from 1 to n because I'm going to start with the first one and I'm going to go to the nth one, which is the last one. Sometimes people get confused with these, the endpoints here, which are actually called the limits of integration. So these are called the limits of summation. These are called the limits of integration. Okay. But that's just what is my x value at the beginning point and what is my x value at the ending point. I'm talking about which rectangle am I on? Am I on the first rectangle? Am I on the 18th rectangle? So I will always start with 1. We always start with the first one. It will always go to n. Okay. Now, that would be my Riemann sum, and I know I want to take the limit as n goes to infinity. So we have set up the limit of our Riemann sum. In the next video, we're going to actually evaluate that.